Hello again, Tomctutor. That's me. Okay, we're looking at the vector equation of a line. No such thing as a straight line, there's only a line. It's a vector equation of a line 3D. In the first part of the video, we set up this vector equation, described what it was. The problem I have now, part 2, is whether this green line is the same as that red line. But it would appear from the diagram they're different. But you have to imagine that this green line here, which is line 2 I call it, line 2, it can be anywhere. Okay, so it's just rotating about and it's anywhere. R1 of course is for first line, so just imagine that to be fixed. So if you're going to figure out if line 2 is the same line as line 1, then it has to be what we call coincident, that is the same line. So the red line, line 1, is given by this equation. This vector 1, 2, 3 of course is the location of the point A1 on line 1, the fixed point, and this minus 1, minus 2, minus 3 is the direction vector on line 1, D1, and lambda is its free parameter. Line 2, the green line, is given by equation 369, which defines a point A2 on this line, plus a mu times 246, so its direction vector is 246. So these, to me, look like different equations. But I'm going to show they're actually the same straight line, and that's the point of this exercise. So I can pick any value of lambda I like for line 1, and if I pick lambda equal to 0, this point B2 is going to land, if that's the right term to use. B2 will actually settle on A1 if lambda is 0. So let's do that. So for line 1, set lambda equal to 0. If I do that, I'm putting a comma here, sorry, I get the R1 will just be 1, 2, 3. 1, 2, 3. Okay? Which is just the point A1, of course, with coordinates 1, 2, 3. So that'll bring that point down there. I can also arrive to A1 on the green line if I pick a suitable value for mu, which is its free parameter. So for line 2, let mu equal to minus 1, and we see that R2 now just becomes 3 minus, well, just becomes the same 1, 2, 3, which is obviously the same point. Okay, which will just arrive at A1 again. We want the same point. There, that guy there. Okay, so I've shown that the two lines contain the same common point. So, condition 1, they have the same common, they share a common point. That's what we say. So the two lines share a common point. Okay, and that is the first condition for two lines to be coincident. They have to have a common point. They have to intersect somewhere. Otherwise, they can't be the same two lines. So if it fails this test, then they're not the same straight line. Okay. But that isn't all the conditions. Not only have they to share the same common point, but they also have the same direction. Now the direction D1 of the red line is given by this vector here. So D1 for the red line is actually just 1, 2, 3. And that's that direction there, D1. Now, I know what you're saying, that's minus 1, minus 2, but that all that is just minus D1, which is this vector here. It's just the same vector as D1, but in the opposite direction. So minus D1, if you like. So it doesn't matter which direction it's that is just a scalar minus d1, it's just a scalar multiple of d1. Okay, so the direction here is 1, 2, 3, but the direction for the second line is 2, 4, 6, and that's just a scalar multiple of 1, 2, 3. So d2 as a vector is just 2 times 1, 2, 3, if you like. I can put a minus in here, sorry, be a bit more precise here. So d1 is minus 1, 2, 3, and d2 is 2 times 1, 2, 3. So d2 is just a linear multiple of d1. Essentially d2 is the same vector, same direction anyway as d1. So we now have the second condition for points on a straight line, and the second condition is that the lines on the same direction as have the same direction vector. Two conditions are met, therefore ergo they are the same straight line. Now it wasn't obvious from the diagram, but I'm just setting the problem up here, okay, because it may not have been the same straight line, but indeed they are the same straight line. So this green one actually runs along there, as does the red one, and that's the end of the problem. Thank you very much. Bye.